Okay, we're back. We're going to look at graphing. Before we do this, some aspects to logarithmic graphs. So let's put them down. So our domain for logarithmic graphs is going to naturally be the interval where our graph can equal 0, and this is always going to go up to infinity, just the basic graph. Our range is likewise going to go from negative infinity to infinity. We'll look at a graph here briefly just to see. Our x-intercept is going to always be 1, 0. Sorry, 1, 0. And it is always increasing, just as our other one was also increasing. It is 1 to 1. Sorry. It is 1 to 1, which means therefore has an inverse function. Okay, and the y-axis is a vertical asymptote where log base a x as it approaches negative infinity is it approaching as x approaches 0 from the right. Okay, this just basically means so at the graph will approach negative infinity as our x approaches 0. It's continuous and it's a reflection of the graph y equals a to the x about the line y equals x. Okay, so let's look at possible ones. Apologies. Okay, so first thing we want to see is we want to see the graph f of x equals 10 to the x. Okay, and we're going to have the line y equals x, and then we're going to do the g of x equals log of x. And if you notice, our graphs actually are reflections of each other. Okay, they flip the x and the y. If we zoom in, we'll see that they flip x and y. Over that implies these two are inverse functions. Okay, so because they flip over the exponent here, from the exponential to the logarithmic, those are inverses, which means we can use them to cancel each other. Okay. Okay. So let's evaluate some for, and then so that's aspects, that's inverses, and then finally transformations. Transformations are just going to be our normal A, B, C things that will affect the stretch, the vertical shift, horizontal shift, and reflections. Okay, use a calculator to calculate this. So you just plug in natural log of 2, and you'll solve it. Natural log of 0.3. So this would become, what would this be the value? This value would be 0.69 472, and this one would be negative 1.2039. Apologies, 728. Okay, this would have to be an error, and then finally this one would be 0.813736. Okay, so these are the different, just calculating it, just plugging in a calculator. Okay, properties. Natural log of 1 is still going to be 0 because e to the 0 is 1. Natural log of e is going to be 1 because e to the 1 is still e. Natural log of e to the x is going to be x because they're inverses. So e to the natural log of x is going to equal x. And then if natural log of x equals natural log of y, then x equals y. Okay. So using the properties, what would this be? What would this equal? So this would be a negative 1. This would be 5. This would be 0. And this would be 2. Okay? Okay, that will be it for today. We'll practice some problems and work through some of the questions from the book. If you have any questions, let me know.